Okay, properties for rotations. This is from your workbook. Have that ready. So a rotation is really just a position. Okay, so it's a change in position of the figure. All right, so you're spinning it. You're spinning. So the rotation will turn the figure around a point called the center of rotation. Okay, so our center of rotation is that. Let me get that. So what we have is that's the center of rotation. Why is my pointer not going? Okay. Anyway, uh, laser pointer. Okay, I'm not getting the laser pointer. This right here is the center of rotation. So at the right, the triangle ABC is rotated 90 degrees clockwise. Now remember, as you go that direction, okay. That's clockwise. And the other direction is counterclockwise. So as you go clockwise, it's been rotated clockwise 90 degrees, and the resulting figure is A prime, B prime, C prime. And that's what they have done here, A prime, B prime, C prime. Okay, it's below are two more rotations of triangle ABC. So this one right here, they say it's 90 degrees counterclockwise rotation. All right. Yes, that's consistent. And this is 180 degrees clockwise. So 180 degrees clockwise is the same as 180 degrees counterclockwise. You would be in the exact same position. So as you go 90 degrees, it's really nice. As we have these here, if you are in this area, if you go 90 degrees counterclockwise, you're going over here, 90 degrees. If you go another 90 degrees counterclockwise, you would end up here. If you go another 90 degrees, it's here, and then the last 90 degrees is back over there. And the opposite thing if you are going regular clockwise. So, which triangle shows a 90-degree counterclockwise rotation from A? So counterclockwise, that would have to be D. You're going in that direction. Okay, which triangle shows 180 clockwise rotation? Well, that's completely the other way around there. That's B. And which triangle shows a 90-degree clockwise rotation? That's this one over here. That is C. And 180, well, they are going to be the same. B. If the sides of triangle A have lengths, okay, so if this has lengths 3, okay, I'll go with 3 there, 4, and 5, what are the lengths of triangle side B? Oh, okay, well, they would be the same. This is 3, this is 4, and this is still 5. 3 centimeters, I guess I should say. 3 centimeters, 4 centimeters, and 5 centimeters. Explain why the answers 2 and 4 are the same. Oh, because 180 degrees in either direction will place you in the same spot. Okay, that went kind of quick. Anyway, if you rotate figure A 90 degrees counterclockwise would be this direction. What quadrant would it, 90 degrees. So if you're going 90 degrees, you're going into quadrant from 2 to 3. So that would be in quadrant 3. If you rotate figure A 270 degrees counterclockwise, so that's 3 90s. 270 is 3 90s. So that's 1, 2, 3. What quadrant are you in? You're in quadrant 1. I saw some there that I want to see. Okay, if you rotate figure 8 180 degrees clockwise, well, that's 2 of them, you're in quadrant 4. 360 degrees, 108, oops. Oh yeah, 180 degrees clockwise, or yeah, counterclockwise, same thing. 360 degrees clockwise, well, that's 1, 2, 3, 4. You're back to quadrant 2. If the measures of two angles in figure A are 60 and 120, okay, so maybe they're saying maybe this is 60 and this is 120 degrees. What would the measure of two angles be in the rotated figures? They would remain 60 degrees and 120 degrees. That's a terrible and. A-N-D. It's better. Yeah, the big idea is when you rotate a figure like this figure A, if you rotate it, you have not done anything to the shape of the figure. All the angles are preserved. That's a very important property when dealing with rotations.